Hello, my name is HARISWAR and I present the for the free convection. And first starting, we turn on this switch and go for the switch. For the first test, we will use a flat surface for the free convection. And then we will turn on the power. We should slowly adjust the power to 5 watts. Then we adjust the power to 15 watts and record the data for the fixed power of 15 watts. Okay, for the next step, we will take the heat surface of pin and pin surface of the 15 watts to for the surface and dump inlet pin.
Just now we done with our free surface, flat surface. So now we're going to change to our pin surface. Just took out the flat surface.
Tolong ke depan. Bulat tuh.
So once fixed our pin surface, we can take our temperature reading. That's all.
Okay.
Once fixed our pin surface, then we have to rise up our watt for 5 for 10 minutes. Raise 5 kilowatts for 10 minutes. Okay, now at 15, then we have to change for 20 watts. Once changed to 20 watts, we have to take the temperature readings.
Done. Okay.
Okay, then once we done our experiment all over, so we are going to shut down our machine. So first of all, we have to shut down the thing. Then shut down this switch. Then the main switch. That's all from me. Thank you.
Hello, Assalamualaikum. My name is HAZRIQ bin JULAILI, and today I'm going to show you the result and data for the lab 3 of heat transfer free convection. So as you can see, table 1 show the fixed power between these 3 different heat transfer surface. As you can see, T2 representing the surface temperature, T1 is the ambient temperature. So and then we got the delta T or temperature difference, which T surface minus T inlet or T2 minus T1. So as we got the data, we gain the flat plate temperature difference is the highest among the other two surface, which record at 41 Celsius. So next is the table 2 or fixed power up to 50 watt for fin surface. So this is our data up to 50 watt, and this is the temperature difference, which are T2 minus T1 or temperature of surface minus the temperature of ambient. We got the maximum of 53.5 temperature difference at 50 watt fin, and this is the pin surface up to 50 watt. So same as before, the temperature difference we get T2 minus T1, or temperature surface minus temperature inlet. So the maximum we record at 50 watt is 35.4 for pin surface, and the fin surface is 53.5. Alright, now we jump into the discussion. So we have created a suitable chart for our result, and we have gained the comparison between three different surfaces. So we recognize that flat plate is the highest, have the highest temperature difference among these three. So the flat plate recorded the highest among the other surface because the flat plate has a bigger area surface compared to pin and fin, right? And number two is give an example of application of surface you mentioned in any system that you know. So the application of plate surface is used in a plate heat exchanger to transfer heat from one place to the other place, right? So this is the chart. Temperature against power, horizontal axis, and what I can say is the fin type temperature is higher than pin type temperature. Obviously we can see that at 50 watt the temperature difference for fin is higher than pin type, which 53.5 and 35.4. So that's all from me. I will let my friend to continue the discussion. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is ADIE ZULFIKRI bin MAZLAN. So I will proceed about this discussion on free convection BMMH3553. Question number 2. Calculate or estimate the gradient for each graph. For your graph, what can you predict about the gradient for another surface, pin or fin, for this experiment? Compare the two gradients and give reason for your answer. So this our group got a gradient for pin type is 0.73 and fin type 1.27. Because the gradient has a value of 0.73, the temperature difference will be smaller as the power increases. The temperature difference on the fin type surface will increase significantly due to the gradient of 1.27. Because the pin type surface's gradient slope is lower than that of the fin type, it will not rise as much as the fin type surface. Fin surfaces transmit heat more uniformly and produce better convection than fin surfaces, for example. Number 3. These two suggestions on precaution steps that you can take to minimize the time to stabilize the surface temperature. So while running the experiment, keep the gradient temperature as low as possible. The temperature of the environment could influence the experiment's result. Air circulation must be as smooth as possible. The experiment should be carried out in a well-ventilated environment. So the conclusion, we got that the more the power, the greater the temperature difference. Second, able to identify the different type of heat transfer surface and the ability to dissipate heat. Third, got to know when the more heat travel, the temperature will become lower. Number 4, identify that the flat plate recorded the highest among other surfaces because the flat plate has a bigger area surface compared to pin and fin. And last, able to find out the pin type recorded the lowest temperature difference between flat type and fin type. That's all from me. Thank you.